In section 1.2, we discuss writing expressions, equations, and inequalities. How does the English language translate to mathematics? So in this first section, we're looking at words that describe a type of mathematical operation. This first list, sum, more than, increased by, total, and plus, all describe the operation of addition. And obviously we use this symbol to describe addition as well. We might say sum and total refer to the result of adding two or more numbers. The second group of words represents subtraction. And the result of subtraction is talking about the difference between two numbers. The third group of words represents the operation multiplication. The word product represents the result of multiplying two or more numbers or items. In elementary school, you first learned this symbol as related to multiplication, but once you get to algebra, we kind of shy away from that because using x as a variable. So instead, we either use this dot operator, or you might even see two quantities being multiplied without anything written in between. So we might have parentheses around one or both numbers, and it's implied that these two numbers are being multiplied. And lastly, we are referring to division for this last group of words. So quotient in this case is the result of dividing two quantities. You first learned division using this symbol. Again, we've kind of shied away from using that in algebra. You will generally see division using a fraction bar, either written horizontally or a backsplash. Next, we actually want to translate the following phrases to a mathematical sentence or expression. So 3/4 of a number, we'll call that number n, refers to multiplication. So we're multiplying 3/4 by n. In the second one, 5 less than a number g refers to subtraction. Now you might be thinking 5 minus g, but it's actually g minus 5. And we can think about that by using actual numbers. If we say we're referring to a number that is 5 less than 7, then we know we're talking about the number 2. But to get there, we have to take 7 minus 5 rather than 5 minus 7. In the third example, 3 more than twice a number x. So I know 3 more than refers to plus 3, but twice a number means I'm multiplying that number by 2. So I might say 2x plus 3 is the translation of this phrase. The sum of a number, f and 8, refers to addition, so I just say f plus 8. In this next one, 60 miles per 2 hours. So per represents division, so I have 60 miles divided by 2 hours. And that's how I would represent that mathematically. And lastly, we have difference between 8 and a number. So I must start with the number 8, and I'm subtracting y from that number. If I had said difference between a number y and 8, then I actually would have reversed that process. So in this next section, we are talking about what a rate actually is. So a rate is a fraction that compares two quantities measured in different units. So that example above of 60 miles per 2 hours is an example of a rate. Another type of rate we use often in our lives refers to the price per say, pound of something. So maybe you go to the grocery store and it's $2 per pound of apples. So we're comparing money or cost to the weight of something. So that is considered a rate. We might also say, cost per gallon. So when you're buying gas, that is also a rate. And then a unit rate is simply a rate when the denominator of the fraction is 1. So this is an example of a unit rate since the denominator is in pounds and we're referring to 1 pound. So next in this example, we're actually going to convert the speed of a roller coaster from miles per hours to feet per seconds. So first, we want to do that by simplifying this miles per hour or this speed to a unit rate. So 240 miles every 2 hours is the exact same as 120 miles for every 1 hour. So we'd say 120 miles per hour is our unit rate for the speed of the roller coaster. But then to convert this into feet per second, we actually will be multiplying this ratio by other ratios that are equivalent to 1. So what I mean by that is first I want to convert miles into feet. Now, since I know that there's 1 mile for every 5,280 feet, I'm actually multiplying this quantity by 5,280. But including the units is important because what happens mathematically is these units divide out. So now if I simplify, I have 633,600 feet for every 1 hour. So I've now converted my speed from miles per hour to feet per hour. But I still have to change my number of hours to my number of minutes. So in this case, I know that there are 60 minutes in every 1 hour. So I need to take this quantity and multiply it by 60 minutes. But what's really happening is I'm taking this total ratio right here and multiplying it by the ratio of 1 hour for every 60 minutes. And again, my hours divide out, and I'm left with 10,760 feet every 1 minute. So to get that number, all I did was take 633,600 and divide by 60. And then I still need to convert minutes into seconds, so I'm actually going to apply the same idea. And since there are 60 seconds every minute, I'm taking 1 minute times 60 seconds. But again, in reality, I'm multiplying this whole ratio by the ratio of 1 minute per 60 seconds. So my minutes divide out, and I take 10,760 divided by 60, and I'm left with 176 feet for every 1 second. So now I know that the speed of the roller coaster travels at 120 miles per hour, but that's the exact same speed as saying it travels 176 feet per second. Next, we have the definition of an equation, which is simply a mathematical sentence formed by placing an equal symbol between two expressions, whether they are algebraic or numerical. Whereas an inequality is quite similar, but instead of an equal sign, we have one of these 5 symbols. So less than or equal to, greater than or equal to, or not equal to. So again, that refers to an inequality versus an equation. Now, these symbols could have another way to express them. So in the center column is the meaning, but there might be other phrases we use to describe them as well. So the meaning is equal to could mean the same as, literally the phrase the same as or equivalent. The symbol is less than could also be referred to as fewer than. Less than or equal to could be referred to as at most or no more than. The symbol is greater than could be referred to as more than. And greater than or equal to might be referred to at least or no less than. Next, we're looking at what does it mean to be the solution of an equation or inequality. So this is simply the value of a variable that makes the equation or the inequality true. So if I said 5 equals 5, that is a true statement, compared to if I said 7 equals 5, that is not a true statement. So in this example, we're checking to see if 8 is a solution to the following both equation and inequality. To determine that, I need to substitute the number 8 in for the variable itself. Now, at this point, I'm still not sure if this is a true statement or not, so I simplify by multiplying 9 times 8. And then I can actually subtract 4, and I see that my statement says 68 is equal to 70. Since this is a false statement, we would say that 8 is not a solution to this equation. In this inequality, once again, we have to substitute 8 in for our variable, so 4 times 8 plus 8 is greater than 10. Is that a true statement? Well, we might need to simplify to figure it out. So 4 times 8 is 32, plus 8 gives us 40. So our statement now says 40 is greater than 10. And yes, this is a true statement. So 8 is a solution to this inequality. Sometimes we use mental math to solve an equation. This usually only happens when there's only one step or operation to think about. So in this first equation, 6 plus y equals 14, we could think to ourselves, 6 plus what number equals 14? And that would be the number 8. So y equals 8. In the second statement, 9 times b equals 27. So we're thinking, what number times 9 equals 27? Telling us that the solution to this equation is the number 3. Next, I want you to take a moment. If you plan on being in class tomorrow, you can stop the video right here and not do this section, but if you know you will not be here tomorrow, then take a moment to try these problems yourself, pause the video, and then hit play once you've tried them to see what the answers are. So in this first problem, you are converting yards per hours to feet per second. So I did actually convert yards to feet before making this a unit rate, but you'll find that this still can work out. So I multiplied by 3 feet per yard so that the yards units divide out. I got 60 feet every 2 hours. I then simplified that to a unit rate of 30 feet every 1 hour. I then converted hours into minutes by multiplying by the ratio 1 hour per 60 minutes. And I got 0.5 feet for every 1 minute. And again, I converted minutes to seconds by multiplying by the ratio of 1 minute for every 60 seconds. And in the end, I got a speed of 0.0083 feet per 1 second. I might also say that that is 83 ten-thousandths feet per second. So this next one, we start out by substituting 3 in for x, but I have to simplify to figure out if this inequality is actually true or not. So 5 times 3 is 15. 15 minus 8. And 15 minus 8 is 7. And is 7 less than 20? Why, yes, it is. So yes, or I could say true. So 3 is a solution to this inequality. Make sure you complete the practice questions by the end of the week, and you only need to do the circled ones.